What we're going to be talking about today is self-driving, self-racing cars and the awesomeness that you can build on your own. So without further ado, let's get started. So first things first, in case you guys don't know, I'm the founder of Hack in the Box, one of the guys that's responsible for answering most of the emails. If you've ever sent an email to conferenceinfo@hackinthebox.org, most likely I'm the guy who actually replied. If you guys want to follow me, I'm on Twitter, L33tdawg. And a little bit more, I used to write code a long time ago. Now I write emails, mainly. But I'm also an AI and ML enthusiast, so I spend my days in between writing emails, building models, screwing around with machine learning stuff and some AI stuff. I also live in Malaysia, in case any of you guys were wondering. I have 2 cats. They're more famous than I am. They've got more Instagram followers anyway. If you guys want to follow them, they're called Null and Void because, well, hacker, you have to have cats that have hacker names, right? So the twin cats, Null and Void, they drive me crazy. They ruin all my furniture, which is why I have hardly any furniture. And so, when we talk about AI and self-driving cars, pretty much these 2 papers are like, quote-unquote, state-of-the-art, right? There's one paper that came out, if I'm not mistaken, in June of this year, which is the deeper car. And both of these papers, while they're essentially what we would call state-of-the-art, they work essentially on the same principle. Thanks, man. They're essentially taking input from various sensors that are on the vehicle. Then you train your neural networks on those things, and then, it drives itself. So, if you want to get into self-driving cars, self-racing cars, I'm guessing most of you guys don't have like a couple of 100K just lying around, not doing anything with it. So, what can you do? The mic has suddenly become soft. Is to look at this project called the Donkey Car Project. This is what it looks like, the little picture on the left. They're essentially a Raspberry Pi with a small little camera on the front of it, and it's behavioral cloning. So while it is machine learning and it is artificial intelligence to some extent, they're very basic, right? Like a real self-driving car, like a Tesla, for example, has numerous different sensors, LiDAR, radar, cameras obviously all around the car as well. This has one camera. So it's not like a super complex self-driving car, but it allows you to experiment and it allows you to learn the principles that would be needed if you wanted to get into autonomous vehicles and you wanted to start building your own self-driving car. So how does it work? Essentially, you are steering it and it's taking the camera input, which is what the car would be seeing. And so the camera that's on the Raspberry Pi, it's got like a very limited depth of field of view, and it's looking for like a center line and the 2 white lines on either side. It's taking the input from, as you're driving the car, it's behavioral cloning, so it's pretty much trying to follow what you're doing. So as you drive it along, it's taking your throttle input, it's also taking in your steering angles, and with those 2 things, you pump that into your neural network, and hopefully the car will drive itself, right? And so, on a more technical level, it's a convolutional neural network, basically. And so you've got like a 120 pixel high image by 160. You've got 3 RGB channels. So that forms your vectors. And then you pump that into a convolutional, I think it's like 9 layers, maybe 10 layers. So it's not even a deep neural network, as what they would call, right? Like it's 9-layer neural network, man. It's not that deep. But most of the state-of-the-art papers are all essentially doing the same thing, right? In a nutshell, obviously, some might be a little bit more technical. They might do some kind of like sub-models on a model, and maybe they have 2 generative adversarial networks trying to like learn it from each other. But essentially, they're all convolutional networks anyway. So, step 1, take a picture, right? You take that from the camera input, you pass that over as your user input. So as you're driving the car is using, I should have brought the car. It's actually at the AI Village. You guys can come over and check it out in a bit. But it's taking, you have like a PlayStation controller that's on Bluetooth connected to the car, and it's taking the input from that via HTTP post on a web server that's running on the Raspberry Pi. So it's like I said, it's taking your throttle values as well as your steering angles. As you drive it around, it's recording all of this along with the images that are coming from the camera. And then we use that to update the servos. So all of the RC cars are using PWM, so pulse width modulation, And so those signals are actually translated from the Raspberry Pi to your servos, and that's actually controlling your actual car. And you use that, you save it into a data frame, so you've got your pairs of data. So you've got the actual images that are coming from the camera, and then you've got the steering input and the throttle input, and those two things is saved as a JSON file, and then you pump that into your neural network. And so it all runs on Keras, TensorFlow. How many people here are familiar with that? Okay, cool. At least there's some people in here that are into Keras. I love Keras. I mean, Keras is the bomb because TensorFlow, if you played around with neural networks at TensorFlow, like sub 1.0 or 1.0, between 1.1 all the way to 1.6, it's like a pain in the ass because it's very, very, very low level. The amount of code that you need to write just to get a basic functionality working makes it quite tedious to build models and to experiment. But Keras abstracts a lot of that away from you, so you don't actually need to know about the actual tensor values. You have a high level. You can just pretty much, this is like the actual code from the autopilot itself. And as you can see, it's not that difficult to read. I mean, it's like human readable. You can kind of understand it. You're building like, convolutional layers of various sizes with the strides. And then you flatten all of that. You've got a dense. You do some dropout. Not usually the best idea, but considering this is a Raspberry Pi and this is like really very small compute power, you can't do too much or too complex computations on it. And basically with this model, you would have a car that can follow a line. At least it'll follow the yellow line in the middle of the road, and it's looking at the two side lines, and it's trying to clone your behavior. So if you were to build yourself a track, could be a small track, could be a big track, you'll need to drive it around the track probably between 8 to 10 times to get enough training data from that. And then you'll pump that into your neural network and train on it. So when you talk about the hardware, it's not expensive, right? A real self-driving car, a real Tesla with all of its hundreds of thousands of dollars of equipment is beyond most people's budget. But you could build yourself a donkey car for $305 US, which is pretty good. It's quite cheap. You can actually get all of this stuff online. So if you don't want to buy it, you can buy it as a kit if you wanted to, or if you already have some of these parts. This is like the cost breakdown of what it would take. There's actually a store that you can go to, and they will ship you the actual car, plus the Raspberry Pi, plus the camera, plus the 3D printed little chassis where you can mount the camera onto. It comes with all the nuts, all the bolts, and it's quite easy to put together. I mean, it's essentially already built, and you just have to tighten the nuts. And then on the software side, if you already have Raspberry Pi, then this helps a lot because you can actually start experimenting. There's an actual simulator, which I'll talk about in a little bit. But if you already have Raspberry Pi and you don't have the kit, but you just want to play around and learn a little bit more about neural networks, you can download like a pre-built binary. It's a zipped image, basically. You just like download that, flash it to the Raspberry Pi. And then on your host machine side, you'll set up your virtual environment, install all of your TensorFlow stuff. If you ever try to compile that from source, like it's going to take a day and a half. So use the pip installer. Really helpful. Saves a lot of time. And so, as I was mentioning, there's a simulator. And it's built in Unity. If any of you guys are gamers, you'll definitely be familiar with the Unity engine. And the simulator helps tremendously because you're going to crash. The first time you compile your neural network onto the car and you like self-drive, it's not going to end well. It's pretty much going to end in disaster. So I would strongly recommend downloading the Unity simulator if you really want to get into this as a hobby. There are teams all over the world. In fact, the Donkey Car project, if I'm not mistaken, is out of the US, but they've got community groups in Hong Kong, also in Europe. So check out their Slack channel. And if you have your own kit, obviously it's no fun playing with yourself, racing against yourself. So join the Slack channel because there's a lot of other guys that will probably encounter the same set of issues that you would have. Like you might find that, the car doesn't really do what it says it's supposed to do. I've trained it, I've driven it around 200 times around the track. It still crashes, it still doesn't follow the line. Join the Slack channel, download the Unity simulator. It allows you to experiment more, so you can actually start playing around with let's just say you set your dropout at 0.5, doesn't really work so well. set it at 0.3, try 0.7. You can experiment a little bit more, and that helps tremendously because trying to compile the model on your host machine and then transferring that over to your little car takes a lot of time. Whereas if you have a simulator, then you can just compile it, move it over to the model, run it in the simulator, see if it works. And so, what are you going to do with all of this stuff, right? We're actually putting together a challenge for next year's Amsterdam conference. And we're going to provide hackerspaces, hackers, enthusiasts, students, whoever, like anybody in this room basically can join this contest. We're still formulating the rules of it, so I figured, we'll probably give each team 2 batteries and we'll model it after like the Formula 1 style of competition, basically, where we have maybe 2 or 3 days of open practice. We'll build a track. We wanted to build it outdoors, but then being that it's Amsterdam and it always rains, we thought, not such a good idea. Electronics, water doesn't really work so well. So we're trying to find a space that's indoors where we can actually set up a track, and you can bring your cars with you. If you already have a donkey car kit, bring it along. And if you don't, we'll provide you guys the kit. So we obviously can't provide a kit for like 100 teams. So we're inviting people to register. If you want to join us, the competition is going to be running at the Amsterdam conference, which is on the 6th to the 10th of May. Excuse me. So 6, 7, and 8 will have your free practice, and then we'll probably do a qualification round on the 9th. And then the top 10 teams will move on to like final race day. And in addition to that, how many people are familiar with the Movidius neural compute stick from Intel? It's pretty much like a little USB thumb drive that lets you offload a lot of the neural computing power that would be on your Raspberry Pi to this device. And that allows you to go faster, go harder, go better. I'm still hacking around with it, and it sort of works, but there's now a new Movidius NC2 version 2 that has just come out. Apparently it's abstracted a lot of the APIs out, and it makes it a lot easier to implement it because the initial version from Movidius from Intel, they have an API, but it's like completely not documented, which is kind of strange for Intel. And there's not really a lot of Python integration going on. But we'll give each of the teams a Movidius, so the guys who actually manage to train their neural network and get the car to run around our track and not crash, we'll give you guys a Movidius so that you can hopefully go faster. And then in Dubai next year, so literally a year from now, we'll be back again here in October. And obviously there's Formula 1 in Abu Dhabi, right? So we thought, what can we do to like make it even more interesting? There's actually a project based out of MIT called Race Car J. It uses a Jetson, which is a small little embedded computing platform. And in this particular instance, so for the Dubai competition, we're opening it up to any engineering teams, any university research teams, to build themselves MIT Race Car J. All the documentation and how to build it and all the hardware and stuff is online. But it's a little bit more expensive. Like the donkey car is like $300. The MIT Race Car J, if I'm not mistaken, with the LiDAR plus the Jetson, the base car, and all the modifications you need to make, brings it up to around $3,500 US. So it's a little bit more expensive. But it'll be fun. And we're inviting any of you guys who are interested in this. The 1/16 scale cars are going to be in Amsterdam, and then the 1/10 scale cars, which are slightly larger, will have an outdoor track. I'm actually thinking of using the outdoor area of the parking lot here because there's like lots of space, and it never rains in Dubai, so that, last 2 days it did rain, but it generally does not rain in Dubai, so that should help. We'll not limit you guys on sensors or hardware, so if you want to put in, 2 LiDARs, 10 LiDARs, up to you, man. Really have at it. We probably might put in some limitations on batteries just to make it fair because, people are going to come up with 20,000 mAh batteries that have 50C discharge, which means the cars can go like lightning, which will not be very fair. So we're still formulating the rules. But if you're a university research team, you're encouraged to apply. That QR code, if you scan it, takes you to a Google form for the Amsterdam conference. So if you guys are interested in signing up and you don't have your own kit, sign up fast because, like I said, we only have 20 kits to give away. So the first come, first serve, the teams that register will get it. If you're going to bring your own donkey car, awesome, then no big deal. There's a little form there that you can fill in and say, I have my own donkey car, I don't need the kit. So you won't deprive other people from having a chance to play. That's it, pretty much. Sorry, once again, that we don't have the right speaker here for you guys, but hopefully this was a little bit more interesting. And if you guys want to see the cars and actually see the hardware that's on it, and you have any further questions, I'm at the AI Village, which is, if you go out of this door, turn left, go all the way down to the end. You can't miss it. It's like the last booth that's on the right. Thanks, guys. Hope to see you guys in Amsterdam. Enjoy the rest of the conference. It's going to be fantastic. I'm quite excited. Have a nice day.
Thank you, Dhillon.